What we're going to look at now is how we would go about calibrating the ROP model in ERA. And what I mean by that is in the hindcasting process, how could we go about figuring out what the efficiency factor is and what the bit aggressivity factor is for a given operation. And in this particular example, I've got some hindcasted data that I've uploaded. And if we click on this icon and we pull up the example that I've preloaded, if we go into the 12¼ inch section where we're drilling, pull up the drilling scenario, and then in this drop-down box, select the hindcast mode of operation. You'll notice that a bunch of data is populated that was actually recorded when this well was drilled. And if you click on the Enter Data section, you can see where you can input information for off-bottom parameters, such as your pickup weight, slack-off weight, and torque, as well as any on-bottom data. This is while you're physically on-bottom drilling: rotary speed, ROP, surface weight on bit, surface torque, those sorts of things. And then, of course, mud properties that were measured as the section was drilled. This is where you would go about back calculating friction factors, calibrating your pump pressure or ECD model, but it's also key to being able to determine what the bit aggressivity factor and the bit efficiency factor is. So I already preloaded this information, and you'll notice that what we've got is our traditional hook loads plot, our traditional off-bottom torque plot, and our traditional pump pressure and ECD plots. Now, if I wanted to go about back calculating the efficiency factor and the MSE, it would all begin with the very first step, which is to make sure that my torque and drag model is calibrated and my hydraulics model is calibrated. And as it turns out, the string weight assumptions that I have, the block weight assumptions that I have, are producing a pretty solid and reliable model. If we open up the hook load model, you notice that my theoretical rotating off bottom weight is lining up well with the actual rotating off bottom weight. So I feel like I have a pretty good handle on the string weight and the block weight. The torque, on the other hand, off-bottom torque, I only have a few data points. This is kind of an unusual example where off-bottom torque wasn't recorded on every single stand. I have quite a bit of data here in the middle of the run, but only a little bit of data at the beginning and in the end. But if you look, it appears as though the off-bottom friction factor is fairly consistent at somewhere around a 0.2. What ERA is going to do is take the actual measured off-bottom friction factor whenever I have that data, and when there isn't any data, it's going to use the previous data points until I get new and better information. Well, it looks like on average we're probably going to be hovering somewhere in the neighborhood of 0.2 for most of this well. Pump pressure, if we pull up this plot so you can see the legend, you'll notice that I've got theoretical pump pressure in teal, and then I've got actual measured pump pressure in little brown circles. And it looks like the model's matching up really well. Back calculated BHA pressure and back calculated bit pressure are in gold and purple. Now, likewise, my ECD model looks like it's lining up reasonably well towards the end of the run. I've got my measured ECD in little brown circles, and then calculated ECD clean hole in blue, and with cuttings when there is with this teal curve. And then, of course, my mud weight is the black curve. Okay, so I have a pretty good torque and drag hydraulics model established. Step one completed. Now the next step is to figure out the bit efficiency factor. And I do that by scrolling over until I get to my MSE plot. And I went a little bit too far here. You notice that we've got 4 different plots that you don't normally see. On-bottom surface torque, TOB stands for torque on bit, ROP stands for rate of penetration, obviously, and then we've got our mechanical specific energy. Well, let's just focus in on mechanical specific energy and rate of penetration. I'm going to scroll over a couple of plots. Right now, my sensitivity analysis is on friction factor. If you notice where the dialog button, the little radio button is pointed. And I'm going to keep it there for a minute. First thing that I need to do, and if back up a step here, by default, ERA is going to assume an efficiency factor of 0.35. And so the way this model would have looked straight out of the box with a 0.35 efficiency factor is to have actual MSE calculated from the parameters that we've measured, wavering as we go up and down this section. compared to the black curve, which is my confined compressive strength, which I obtained from a geomechanics consulting company. They provided the confined compressive strength versus depth. And you notice the two don't line up very well. So the first key in calibrating the model is getting the efficiency factor dialed in so that MSE and the confined compressive strength are as close as possible. Well, since the actual MSE is considerably higher than the compressive strength, that must mean that we're not as efficient as we've been assuming. So I might adjust this efficiency factor to say 0.15. And it'll recalculate. And you notice now that we get a good match early on in the run, but it appears for the bulk of the data that my MSE is actually too low. So it looks like I went too low on that first assumption. If I try something a little bit higher, maybe 0.25, now we get a quite a bit better match. Maybe not perfect, but better than where we were before. A little bit lower. That looks pretty good. So I'd say a 0.23 is about where we're hovering with our efficiency factor, if we just focus in on that MSE curve. Now, if we move over to the next plot, ROP, if I was to focus in on the rate of penetration and the torque on bit, now, my dark blue curve is the inferred torque on bit, and the light blue curve, or teal curve, is my predictive torque on bit. And when I've got the right bit efficiency factor, or sorry, bit aggressivity factor, then these two curves should line up reasonably well, and the rate of penetration curve should line up reasonably well. Purple is theoretical ROP, black is the actual ROP. Already I've got a pretty good match, but I think I can do better. If we click on the BAF sensitivity, this will give me a series of different squiggly lines, and it's kind of hard to see which is which. But it looks like somewhere around the green curve. So the green curve would be one increment lower than what I'm actually operating at. So I might just switch back to friction factor to make it easier to see. One increment lower would be a bit aggressivity factor of 150. And with a bit aggressivity of 150, theory and reality now match surprisingly well. I'm really happy with the fit that I get on ROP, and I'm really happy with the fit that I've got on my torque on bit with a bit aggressivity factor of 150. And I'm going to zoom back out to a 4-plot view. You can see my MSE, my rate of penetration, my torque on bit, and the theoretical and actual surface torque while I'm on bottom drilling all line up quite well. So if I was going to do any forward modeling, the assumptions I'd go forward with is an efficiency factor of 0.23 and a bit aggressivity of 150, assuming that I use the same bit. That's how we go about calibrating those key parameters for our ROP model.